Good day to all of you. Today we shall study threaded binary tree. Our sincere thanks and acknowledgement to authors Ellis Horowitz, Sartasani and Susan Anderson Freed, authors of the textbook with title Fundamentals of Data Structures in C. So all the basics regarding what is a tree data structure, what are the terminology involved, what is meant by binary tree and different kinds of tree, and what are the different traversal techniques in case of binary tree, that I have covered in my previous videos. You can refer to them. To recall here, what is a tree data structure? Tree data structure is a non-linear data structure which organizes data in hierarchical structure, and this is a recursive definition. Tree data structure is collection of data which is organized in hierarchical structure recursively. Then what is binary tree? If a tree has at the most 2 children for all the nodes in the tree, then that tree is called as binary tree. Okay. Then what is a threaded binary tree? Threaded binary tree is also first a binary tree, but in that the nodes will store in order predecessor for left child pointers if they are null, in order successors if right child pointers are null. Okay. For the nodes whose right pointer is null, we stored in order successor. If left pointer is null, we store in order predecessor. If this procedure is done on existing binary tree, then binary tree will become threaded binary tree. The leftmost and rightmost child pointer of a tree, they always point to null because they will not have in order predecessor and successor. This is what is the definition of threaded binary tree, and in the next discussion we shall study this in detail and what is the meaning of this. And given binary tree, how to construct a threaded binary tree, and given data elements, first how to construct binary tree and then construct threaded binary tree from that. Okay. So if this is the given binary tree, the final answer threaded binary tree is this, which is obtained from the given binary tree. In that what is made? If left child are null, they are filled with their in order predecessor addresses. If right child of a node is null, it is filled with its in order successor address. What are the different types of threaded binary trees? So there are two types, one-way and two-way threaded binary tree. These two are one-way threaded binary tree. This is called as right threaded. This is called as left threaded. What is meant by one-way threaded binary? One-way threaded binary means only right child pointers or left child pointers are considered. If right child considered, that is right threaded binary tree. If only left child are considered, there that is called as left threaded binary tree. Here in this right threaded binary tree, right child, if they are null, they are made to point to their in order successor. In left threaded binary tree, if left child is null, they are made to point to their in order predecessor. If both are found in only one tree, then that is called as two-way threaded binary tree. So before going to learn the construction of threaded binary tree, why threaded binary tree is required, let us know. Because in the given binary tree, many nodes will have the null pointers to their left child and right child, and this space is utilized in case of threaded binary tree. These special pointers are called threads. The binary tree having such pointers is called as threaded binary tree. So if this is the given binary tree, this is threaded binary tree because their left child or right child, wherever null values are there, they are made to store their predecessor or successor, that is ancestor's address. So they are called as address pointers. These will be address pointers. And the binary tree which has such special pointers that is called as threaded binary tree. This, before going further, one point we have to note down: the given binary tree can also be represented like this. This is one node, it can also be drawn this way. One memory location storing the data element, another memory location storing its left child address, another memory location storing its right child address. These two are address pointers and this is storing the data. So this one set of three memory location forms one node. So this tree is drawn using this notation. So the same tree can be drawn in two ways. So this notation we will follow. Okay. Next we shall study with an example how to construct threaded binary tree if a binary tree is given. So this is the given binary tree now. For this we shall learn how to construct the threaded binary tree. Step 1 is first find in order sequence for the given binary tree. In my previous video, I have already explained how to find in order sequence or traversal sequence for the given binary tree. Recalling, if we start from this point and move in this, which is marked here in that path, it cuts this blue line here. So node 5 will have to note, then continue in this direction, it will cut blue line here. This is 6, that node we have to mark. Again continue, it cuts blue line here, so mark node 9. Then we continue our movement in this path, it cuts here, so it is 10. So next continue, it cuts here, so after 10 we have 13. Next if you continue, it will cut here, it is 20. So continue and this path, and then we will reach the finish point. Now the procedure is over. So this is the in order sequence that we have got for the given binary tree. That is 5 to 6, 6 to 9, 9 to 10, 10 to 13 and 13 to 20. This is needed for the step 2. Next step 2. In step 2, if right pointer is null, store in order successor of the node if it exists. If left pointer is null, store in order predecessor of the node if it exists. For this we have to consider the in order sequence which we have found in the step 1. This is the in order sequence that we have found for the given binary tree in step 1. Now according to this point, if you continue, so for node 5, its right child is null. Here 6 is its in order successor. So 6 is the in order successor of 5. Hence in right child, its in order successor address is stored. Similarly for 9, its right child is null. So here its in order successor. For 9, 10 is the in order successor. Hence this address is stored here. So these two are according to this point. Okay. Next, according to this point, if left pointer is null, store the in order predecessor of that node if it exists. So 9, if you take, its left pointer is null. So here we have to store in order predecessor of 9 address. So for 9, in order predecessor is 6. Hence here node 6, its address is stored here. For 20, the left child is null. Hence there in order predecessor of 20, that is 13, its address is stored. For 13, its left child is null. So 13, its in order predecessor is 10. Hence here node 10 address is stored. This is according to step 2. The next point remaining is leftmost and rightmost child pointer of a tree always points to null as their in order predecessor and successor do not exist. Here leftmost is this, rightmost is this. There is no in order predecessor for this node. There is no in order successor for this. Hence both are retained as null. That completes the procedure of constructing threaded binary tree. So if this is the given binary tree, This is the threaded binary tree that we have obtained following two steps. This is the answer. This is the construction of threaded binary tree for the given binary tree. Next, we shall solve one more problem. This is the problem from question paper in the final exam. So here, how to construct threaded binary tree if data elements are given, that is asked. In the previous problem, binary tree was given. From binary tree, we were required to draw the threaded binary tree. In this, we have to draw the threaded binary tree for the given data elements. So, if values were given, the rule we had to follow. The rule is root node should be bigger than the left child node value. Then right child value must be greater than the root node. This we have to follow for all the data elements given recursively to draw the threaded binary tree. But now A, B, C, D, E are given, the alphabets are given, but not values. In this randomly one binary tree we have to draw. For that, considering the following randomly drawn binary tree. For this, we have to obtain in-order traversal sequence. This is the in-order traversal sequence for the obtained binary tree. Then we draw the threaded binary tree from this random binary tree. Here, left child of the node, if it is null, it is filled with the address of in-order predecessor of that node. If right child is null of any node, then it is filled with the address of in-order successor node. And this rule is followed recursively for all the nodes. Leftmost and rightmost are filled with the null because they will not have a in-order predecessor and in-order successor. Then we get this threaded binary tree. So that is the solution for the given problem. Okay. So we can compare our answer with what is drawn here. Lastly, what are the advantages of threaded binary tree? Threaded binary trees provide space optimization because they make use of null pointers to store in-order predecessor and successor. They provide time efficiency because they make in-order traversal faster and efficient. They simplify insertion, deletion and traversal operations. They provide a non-recursive traversal which are less costly performance wise. Next, we shall see to the disadvantages of threaded binary trees. Threaded binary trees are very complex for insertion and deletion of nodes. They need extra memory space because to differentiate threads and ordinary links. Increased complexity we can experience in case of threaded binary trees because they are more complex than standard binary trees. They provide limited flexibility. These are more prone to errors when both children are not present. That completes the whole discussion. Today we discussed on the topic threaded binary tree. In this, what is threaded binary tree, why it is needed, what are the different types of threaded binary tree, then when binary tree is given, how to construct a threaded binary tree, when data elements are given, how to construct a threaded binary tree, then what are the advantages and disadvantages of a threaded binary tree. That completes the discussion. I hope you understood. Thank you.